Good morning, ladies and gentlemen, boys and girls, friends and neighbors. Today we're going to do a video over Unit 7, Lesson 1, Activity 1. We would ask that you fill in your interactive notebook very carefully. We're also going to ask you not to make this difficult. And hopefully you will make the connection from what we did earlier. And I will tell you that this activity is extremely important as we go down the road and study trigonometry. So what we're going to start off doing is looking at the graph of a circle centered at the origin. So we have a circle centered at the origin, and this is the origin here. The equation of this circle is x squared plus y squared is 1. If you don't remember the Algebra 2 analytical equation of that circle, that's okay. It's enough for us to realize that this equation of a circle is x squared y squared is equal to 1. 1 is the radii here. So this guy right here, 1 is the radius. So that's what we need to realize, is that the radius of this circle is 1 unit. In fact, point A, we're going to let that point A, we're not going to let it, that point A is the point 1 comma 0. X value 1, y value 0. And we're going to label the angles on the circle as follows. The measure of AOB is equal to FOE. So this is the measure of angle AOB. So I start at A, center point OB. This angle right here, we're going to do this guy right here. This angle is 30 degrees. As well as FOE is 30 degrees. So we're going to label the 30-degree angles in green. Well, guess what other angle is? FOG is 30 degrees. And AOK. AOK is also 30 degrees. So those are our 30-degree angles. Alrighty. Now we're going to define these points, and then we placed this point B such that AOB was 30 degrees. We placed this point E on the circle such that this angle FOE was 30 degrees. What we're going to do now is we're going to place another point on the circle, C, such that AOC, we're going to do these in purple, AOC is 60 degrees. So this whole entire angle there is 60 degrees. And make sure you realize that this angle right here isn't 60. Oh, well, this angle here then would be 30 as well. But I want to concentrate on this angle AOB, or AOC, we're down here, is 60 degrees, as well as this angle FOD. So again, we're looking at some geometry here, angles. Please don't make this difficult. This angle here is 60 degrees. We place the point D in such a manner that FOD was 60 degrees. And we're going to place the point H on the circle, FOH, so that this angle here is also 60 degrees. And we're going to place this point J in a manner that this angle AOJ is 60 degrees. So what I've done is I have labeled 8 points on the circle, B, C, D, E, G, H, and J, K, such that I have a couple 30-degree angles and I have like 4 60-degree angles. The other thing I'm going to note here that will come into play down the road is this point right here on this coordinate. That point right there is going to be 0, 1. If this circle is indeed radii 1, then this point right here is going to be 0, 1. I'm going to go ahead and label these points. This point F is going to be negative 1, 0. Don't forget what you already know about the x, y coordinate axes. And this is the equation, the Cartesian equation for this circle is x squared plus y squared is 1. So we are in the xy plane here. And the other point I want to label is this point right here. And what would that point be? That point is going to be 0, -1. Okay. Oh, well, let's see here. Oh, what I want to do then is I want to find the coordinates of these points, B, C, D, E, G, H, and J, K. Dude, this is going to take, well, I'm going to look at this one triangle right here. And I'm going to let this be a right triangle. I'm going to look at this red triangle right here. And keep in mind, this point here, what is this long leg of that? Oh, what kind of triangle is this? This, ladies and gentlemen, is a 30, 60, 90 degree right triangle. This distance of a long leg is x. We define that to be x. That's how far over we go. Don't forget how to plot a point xy. Heavens to Betsy. Learned how to do that in the 5th grade. So you go over x, and what do? You go up y. So what I want to do is I want to find the actual, and I claim that I can find the actual value for x and y. And what do we know? Well, we know that this is a 30, 60, 90 right triangle. I'm going to pull that triangle out of there a minute. This is a 30, 60, 90, 30, 60, 90. And what's the hypotenuse? The hypotenuse of that 30, 60, 90 right triangle is 1. Why? Because the radii of this circle is 1. All of these distances from the center to these points on the circle is 1. That's the definition of a circle. Infinite amount of points equidistant from a point. That distance is the radii. So what I'm looking at is this red triangle, because what do I want to do? I want to find x and y. So how do I, whoa, check this out. We've already found this distance right here, and we've already found this distance right here. I'm going to go back. I have the notes filled out, and we've been doing this for a couple weeks. I think it's on this page here, if I'm not mistaken. Let's see here. It's not that page. Is it down here on this page? Maybe it's on this page here. No, we're close. Here it is. Look at this. You will refer to this page often. What do we have here? Here we have this 30, 60, 90 right triangle that has a hypotenuse of 1. We've already figured out that this long leg was square root of 3/2, and this short leg was 1/2. How did we figure that out? We figured that out because of the discussion about half of an equilateral. We don't have time to review this yet again. I would ask that you look in your notes from the last couple weeks about the special relationship of the legs with respect to the hypotenuse on a 30, 60, 90. So we know this. We know the long leg of a 30, 60, 90 is square root of 3/2. We know the short leg is 1/2 if and only if the hypotenuse is 1. So I can go back here to my diagram. Hey, what's this x value? This x value, the long leg, is square root of 3/2. The short leg is 1/2. That's the coordinate of this point B. Oh, well, let's go ahead and find the coordinates of point E here. Well, what do I have? Again, on this point E, what do I have? I have another 30, 60, 90 where the hypotenuse is 1, and I want to find this x and y. What changes? Don't forget, ladies and gentlemen, we are in XY land. This is quadrant 1. In quadrant 2, the x's are negative. Therefore, the point E is going to be negative square root of 3 over 2. The y is still positive because we're in quadrant 2. So I'm going to go right down here and I'm going to fill out E. The coordinates will be negative square root of 3 over 2, comma 1/2. The coordinates were B, we found, were square root of 3 over 2, comma 1/2. And dude, let's go ahead and find the coordinates of G. Well, look at G here. What kind of a triangle do I have here? I have another 30, 60, 90 right triangle with a hypotenuse of 1. What's the long leg? Square root of 3 over 2. But if I'm down here in G, if I'm at this xy, what do I know about that x and y? Well, we're in quadrant 3 here. What do you know? The x negative and the y are negative, but the distance of this long leg and the distance of the short leg are the same. All we need to do is sign those distances. So if I'm G, that's going to be negative square root of 3 over 2 and negative 1/2. I can't tell you how important this page is. If you need to, the only thing you need to do is review how we got that. That's in your notes 2 weeks ago. It's in your notes that you should have filled out yesterday. What point do I want now? K. Well, check out K. I have another 30, 60, 90 still, but I'm in quadrant 4. I'm in quadrant 4. What do I know? The x's are positive and the y's are negative. So I just found the points, the coordinates of points B, E, G, and K. Check this out now. Okay, we'll pause, let that soak in. Let that soak in. Oh, well, check this out. If I look at this, and it's going to get a busy diagram. And we're going to give you some other versions. If I look at this triangle right here, well, what's the measure of this angle right here? This angle was 60. Guess what I have? Another 30, 60, 90. I know the short leg is 1/2. And it looks like this distance right here is 1/2. So I'm going to go ahead quickly and fill in these coordinates. This is going to be 1/2 square root of 3 over 2. It's still a 30, 60, 90. But what happened? The x is now the short leg and the y is the long leg. Look at this point D. The x is the short leg and the y is the long leg. X negative, y positive. Both negative. We're in quadrant 3. Quadrant 4, x positive, y negative. Okay. Pause the video. Zoom out. Pause the video. Okay. Let's do the last page of this particular activity. Let's zoom out. Go to the next page, and here we go. Same circle, different points. This guy right here is still 1, 0. And you know what this point is, 0, 1. Negative 1, 0, 0, negative 1. But I want to point this time, I want to put this point B where AOB is 45 degrees. And DOC is 45 degrees. And DOE is 45 degrees. And AOF is 45 degrees. So what do I have? Uh-oh, look what I have. This is the X, this is the Y, this length, this, all the radii are 1. And what do I have? Here I have an isosceles right triangle. I actually have 4 isosceles right triangles, all with a hypotenuse of 1. Color coordinated, make it look pretty. And so now I need to find what's the length of a leg of a special right triangle 45, 45, 90. This has to be 45 here, folks, because this is 90. 180 minus 90 is 45. These are both 45. Have I figured out previously what the lengths of those legs were? I think I have. Bam! And right here it is, previously in your notes. If I have a right triangle that is isosceles right triangle with the hypotenuse of 1, I've already figured it out that these lengths here are square root of 2 over 2, simplified radicals. Go back and look at your notes. Look at the activity that we did prior last week. And if now I can finish filling out this unit circle here, and we call this the unit circle because it has a radii of 1. So we're going to use this a lot. This is the unit circle because the radius is a length of 1. And we have some very important points on this unit circle. And now xy, I can find the coordinates of B, C. So B is going to be square root of 2 over 2, square root of 2 over 2. The coordinates of C, negative x, positive y. Coordinates of E, negative x, negative y. Coordinates of F, positive x and negative y. Ladies and gentlemen, I can't tell you how important this activity will be with respect to the rest of your study of trigonometry. So you need to be able to come up with these coordinates, and you need to be able to come up with these coordinates. They're going to be very important. And that, ladies and gentlemen, is Unit 7, Lesson 1, Activity. See ya.